Welcome to the new Gravity Housing Conference session, Reaching the Impossible Fourth Story in Source Zero Energy Multifamily Housing. I'd like to take a moment to remind all attendees that everyone is muted with your videos off. To interact with our presenters throughout the session, you can utilize the Q&A feature in Zoom to share your questions with our presenters. We'll be keeping an eye on the Q&A throughout the session, and we'll also have a facilitated Q&A at the end. Please use the chat feature in Zoom for any side and general discussion. We'd also like to thank our sponsors for their generous support of this year's conference. Please make sure you take some time to check them out in our virtual expo hall. Now here's a brief message from our sponsor, ComEd, before we get started with the session.
The ComEd Energy Efficiency Program has been helping owners save energy and reduce their operating expenses in new buildings and buildings undergoing major renovation since the start of the new construction offering in 2009. The program's impact has been tremendous. What you are seeing is a graphic representation of projected annual savings in kilowatt hours for new construction projects that have received both technical assistance and financial incentives from the ComEd New Construction Service from 2009 to 2016. The colorful bars illustrate a variety of building types that have benefited from the program, including manufacturing, higher education, retail, healthcare, and more. The program supports the transformational work of developers, building owners, and design teams.
The ComEd Energy Efficiency
before we get started with the session.
The ComEd Energy Efficiency Program has been helping owners save energy and reduce their operating expenses in new buildings and buildings undergoing major renovation since the start of the new construction offering in 2009. The program's impact has been tremendous. What you are seeing is a graphic representation of projected annual savings in kilowatt hours for new construction projects that have received both technical assistance and financial incentives from the ComEd New Construction Service from 2009 to 2016. The colorful bars illustrate a variety of building types that have benefited from the program, including manufacturing, higher education, retail, healthcare, and more. The program supports the transformational work of developers, building owners, and design teams.
The ComEd Energy Efficiency Program's affordable housing new construction offering provides technical and financial assistance for projects to achieve beyond code energy performance while supporting occupant health and comfort. Eligible projects can be new construction or major renovation. They must be located in ComEd's service area. They must serve income-eligible residents earning 80% or less of area median income, and they must be designed and constructed in accordance with the ComEd Multifamily Standard. Contact us to learn more and get started today. businessee@comed.com.
Thank you again to ComEd and all of our new Gravity sponsors. Now, let's get into our session. I'd like to introduce the speakers for this session. We have Tom Bassett-Dilley, architect and owner of Tom Bassett-Dilley Architects, Scott Farbman, building performance analyst at Database Plus, David Pope, president and CEO, Oak Park Residence Corporation, and Joe Sinnett, associate principal at Kahler Slater. Here are the learning objectives for this session. And as a reminder, the new Gravity Housing Conference is approved for PHIUS, PHI, AIA, and GBCI credit. Thank you all again for joining us, and don't forget to use the Q&A feature throughout the session to ask the presenters your questions. Now I'm going to turn it over to our speakers to get started.
Hey, thank you all very much for being with us here today. We're really excited to be able to talk about a project that has been a significant effort over the course of the last 9 to 12 months that we've been moving forward. But it really is, as we say here, about reaching the impossible fourth story. And I think it'll be an exciting discussion that we're looking forward to having. We want to share with you some of the background about the project, but I want to start a little bit with background about the Oak Park Residence Corporation. Again, I'm David Pope. I'm the president of the Residence Corporation. The Residence Corporation was founded in 1966 and is a not-for-profit organization of 501c3. And we are focused on providing high-quality, affordable housing that also encourages diversity and that fosters that within individual buildings as well as in neighborhoods. We have a $100 million portfolio, a $7 million annual budget with about 35 employees, and we own 29 apartment buildings with collectively between our conventional multifamily apartment buildings, our independent living senior building, and independent living building for persons who are mobility impaired, more than 700 units, and then we manage an additional 800 units that are part of public housing and the Housing Choice Voucher Program here at Oak Park. So collectively, we're responsible for oversight management and ownership of 1,500 units in Oak Park. Oak Park is also a highly diverse community that is also a significant opportunity area. The site that we are working on is a site that is on the eastern part of Oak Park. And as we've gone through this process, we've faced a number of questions that have come up with respect to development in Oak Park that are pretty typical of development in a lot of different areas around the country. Prior to being in the role that I'm in now, at one point earlier, I was on the Plan Commission for Oak Park and was also a member of the City Council, and then was mayor of Oak Park from 2005 to 2013. And in those capacities, I faced a lot of questions about different proposed developments. The ones that I've listed here are ones that are, I think, similar to ones that people face around the country. The first one, that often gets asked is, why does every building in Oak Park seemingly need to be 18 or more stories? Why can't we have new buildings that are 8 stories or fewer? They also ask about geography. Why is all the market rate development occurring in downtown and not in my neighborhood, which more typically means on the eastern part of Oak Park? And then affordability. Why don't more buildings in Oak Park, new buildings, actually encourage economic diversity and incorporate a significant number of affordable units? So we've taken these questions, as well as a few others, into account with respect to the proposed development on this site. In terms of height, we're actually proposing a project that will be only 6 stories. So from a perspective of neighborhood impact, this is seen to be much more reasonable. In terms of geography, the project will bring market rate new development to southeastern Oak Park in an area which has not seen any significant new development in more than 60 years. And then from an affordability standpoint, 20% of the units will be occupied by people earning less than 50% of area median income. And that's a standard for all of our buildings. All of our buildings are economically integrated. The history of affordability demonstrates that folks actually are best able to make progress in terms of economic progression if they live in buildings as well as in neighborhoods and communities that provide for more economic diversity. Other questions that often come up, again, sustainability. Why aren't new buildings here in Oak Park more environmentally responsible in their design and function? In terms of accessibility, the questions are often asked, if I'm a senior or a person with a disability and I live in a building with an elevator, or I need a building with an elevator, why do I have to move to downtown Oak Park? Why can't I live in my neighborhood? And then from an aesthetic standpoint, there's been a lot of criticism of developments in Oak Park not really being focused on high quality design. And so as we've looked at these issues, our effort is to be able to create the most significant net zero multifamily building in the upper Midwest and have it serve as a model. In terms of accessibility, making sure that it's something that is on that eastern part of Oak Park, but that can meet the needs of individuals with disabilities. And then also from an aesthetic standpoint, my insistence from the beginning is that the building must be both contextual and beautiful, otherwise we're not going to build it. So from a site planning standpoint, the building is situated on Austin Boulevard, which is the border between Chicago and Oak Park. Oak Park is a community of 53,000 people. It is a very dense suburban community immediately adjacent to Chicago on the west. And this view of the site plan is actually from the northeast looking back to the southwest. Across Austin Boulevard is a major Chicago park, Columbus Park, and it's a really attractive element to seeing a potential for redevelopment on this site. When we look at the specific zoning envelope within which we're looking to function here, there are setback requirements and a height limitation that are contextually set with the surrounding buildings. And as we think about the need to also have some parking here, we don't have to satisfy a one-to-one parking requirement because the site itself is just a couple blocks from major train lines and bus lines. So it's a very transit-oriented location. But we do have to have some parking on that first floor and access for entryway and stairwells. So when we look at the floor plate really wasn't big enough to be able to accommodate that. So in turn, what we're doing is we're bridging out over the sidewalk into the public way, as well as pulling back from the property line at the north to be able to create a more generous walkway area that we're referring to as a colonnade. And then from that, we're creating an inviting sense of linkage across Austin Boulevard to the park that's across the street and helping to bridge a gap between Oak Park and Chicago that's also an economic gap. Oak Park is a very economically diverse community, but the Chicago neighborhood that it abuts is a very low and moderate income community, and the hope here is to be able to help use this building as an opportunity to be able to link the communities themselves. We also are going to need, from an economic standpoint, to have a greater density of units. And the challenge that we face with the building is to be able to make sure that we can have a building that is big enough to generate the economic return to justify construction. But at the same time, from an environmental and an energy performance standpoint, we need to have a building that is going to have an array or a way to be able to create and generate the energy necessary to be able to achieve net zero, which has been our goal from the beginning. So the project itself is replacing an existing 12-unit California-style mid-century building, which needs significant renovation. We were going to have to make a significant investment here anyway, and to replace it with a 44-unit building with 9 affordable units. So again, more than 20% of the building will be affordable to individuals at 50% of area median income or below. And our goal with that building has been to create really the first significant new construction along the eastern edge of Oak Park in 60 years, as I mentioned. It's sited across the street from Columbus Park, which is a Jens Jensen design jewel of a Chicago park, public park. The project itself will also have a roof deck with a view of the Chicago skyline, which will serve as a significant community amenity, which will be valuable for individuals in both the affordable units and the market rate units as something that really is a compelling benefit to the building with very high quality finishes, both in the units and the common areas. And as I mentioned, it's located within a TOD area. The application that we have submitted to the Illinois Clean Energy Community Foundation, and that process has also been very helpful to us as we've worked through the development of this project. And Tom Bassett-Dilley, who has helped us as a part of the team focused on the energy modeling side of this, has extensive experience both in this area and also working with the Illinois Clean Energy Community Foundation. So I'm going to turn it over to Tom at this point and let him take it from here.
Thanks very much, David. I'm Tom Bassett-Dilley, architect and certified passive house consultant, and I've been doing the energy modeling on this Very exciting project. And I want to talk a little bit about why this project is possible because of the Illinois Clean Energy Community Foundation grant. It's available to nonprofits, local governments, and it's seeking to fund zero energy projects. This is the Illinois Clean Energy Community Foundation's Zero Energy Building Grant. So what you have to do is actually prove zero energy performance. You also have to get a third-party certification such as PHIUS or PHIUS Source Zero, Living Building, Pedal, etc. So it means that you're committing to designing in accordance with a standard and performing according with the standard. So that's how we got involved early on. It's a significant incentive, up to $2 million or 80% of the incremental cost to achieve net zero, which means whatever building you were going to do, the extra insulation, let's say, solar array, certification costs, et cetera, can be covered in part by the grant. So it's been a huge boost to the zero energy and passive house community here in Chicago as nonprofits and municipal entities have stepped up. We've been involved with a few of these. So we jumped right into this project looking at passive house design, and I want to just take a minute to say we're working with PHIUS, the Passive House Institute US, and they update their standard kind of like a code cycle every 3 years. So 2018, what's really interesting is that there's this calculator which you can access online, which is sensitive to the density and size of your building. So if you look at these comparison of a multifamily project like ours, which has a lot of people in it, fairly dense, compared to a single family, when you enter those into the calculator, you get very different space conditioning criteria. So that is a really interesting evolution of the standard. It's not a one-size-fits-all by any means, and it really means that we can sort of be optimizing our building based on not only its climate, but also its use and density. So we went through a really interesting iterative process. Kahler Slater has been great to work with as the architects, kind of bouncing back and forth. And we started the process knowing that we couldn't have an all-glass building, for instance. And it was kind of a funny conversation in the beginning because David, as the owner's side, really wanted a lot of glass. And I said, that's going to be a real problem from an energy standpoint. So we kind of started off with a moderate amount, we all thought, and we took that into WUFI Passive, the energy modeling program, to see how it did. So started with about 37% of wall area devoted to glazing, and we built that from the Kahler Slater model in our little SketchUp model to import into WUFI Passive. So we brought that in, and we're kind of astonished that we could make the heating demand work because there's enough solar gains and there's all these internal gains of people inside and their appliances and, their cooking and their washing and all that stuff, their lights, creating heat. So heating demand wasn't a problem, but man, the rest of it was. No matter how much insulation we put on or took off, we just couldn't get there. So we started reducing our, and I should add, sorry, on that we did look at shading on this as well, and just couldn't quite get there. So we started reducing the glazing percentages down to 30%, and it started to look a little better. But it wasn't until we got down to about 27% that all of a sudden everything got easy. And I want to just clarify, if you're not familiar with the passive house sort of language here, the demand is the annual use. So that's your heating and cooling energy annually. The load is the peak load. So it's interesting thing about the passive house standard is that really requires you to mind your mechanical systems through your passive means by making sure that the equipment doesn't have to be huge and it doesn't use a lot of energy over the course of the year. So yeah, when we got down to about 27% of wall area, we could be at like R36 for the wall, which is higher than code, but it's not outrageous. And that allowed us to get into the happy green check marks you can see there. This is the dashboard off of WUFI Passive. And you're seeing a red X on the source energy because that is the number that we're going to have to offset with our solar. So we just left that alone. We modeled the project in Woofy Passive without solar, so we could figure out if we did everything right for all the other green check marks, how much solar would we need. We did get into shading on this one, and we needed to because the east and west facades, even with relatively low solar heat gain glass, required some shading to keep the loads, the heating loads from, the cooling loads from getting too high. So we looked at sort of obscure metal screens and vertical slats, and we were a little worried about these things because if they're operable, that creates complications for how we model it. If they're not operable, then they can kind of get in the way of the view, and there's this beautiful view across to the park from the east side of this building. So we were a little worried about that. Later on in the design project, the architects kind of got inspired to simplify the plan and kind of change the orientation, and it shuffled the glazing around a little bit. And that little bit was enough that we could leave the shading behind and make it without having to have sort of these vertical screens that we were considering. We do have shadings in the balconies, and they are important for the building to work. As you can see here on the metrics, we're barely making it on our heating load. We're barely making it on our cooling load, but barely making it is good enough as long as we stay there. And we have this source energy to offset of about a little over 6,000, almost 7,000 kilowatt hours per person annually. So we take that into our PV watts, which is our version of being able to try to model how much solar output we need, or how many solar panels we need, let's say, how big of an array to offset that energy. And so we take the number of people that we're predicting through the passive house model, multiplying it times the kilowatt hours per person and getting that source energy. We divide that source energy by the source energy factor, which is basically about 2.7 because of the energy mix in this country to get a site kilowatt hours. And that's the amount that we need to make on site to offset our energy use. Now we've multiplied that times 1.08 because in recent monitoring, PHIUS has found that total energy use is about 8% more on average than Woofy Passive predicts for passive house projects. So we're trying to be safe here because remember, we have to make the net zero work. So that gave us an array of 480 panels, most of which we got on the roof, but a bunch of which we wrapped down the south side of the building. Now, we considered this as something that we might want to be even more cautious about. And mind you, this was before COVID, but we started thinking about, maybe more people are working from home. Maybe people are using their appliances and TVs a lot more than Woofy Passive predicts. So let's do some modeling of that, like added a video game console for 5 hours a day and more cooking and more TVs on, et cetera. And we played around with these to see what they did with the overall energy use and found that we really, to be safe, felt like we needed to kick it up another 12%. So from that 228 kilowatt hours, 228,000 kilowatt hours per year, we bumped that up to about 254, and that became our new target. So it meant more panels, but we are working now with a solar consultant and are able to make it just barely. So it definitely is about the limit of what we think we can do here. Now, what does that look like in terms of architecture? I'm going to hand this over to Joe Sinnett from Kahler Slater so he can tell you about how it turned into not just an energy model, but a beautiful building.
Thank you, Tom. So how can we use the spatial programming to increase the affordability of rental units in a passive house source zero energy building? We found that 5 categories have the largest impact on the affordability of the units, within the biggest impacts being spatial programming of the building. The first step is identify the target demographic in the market and determine the rent levels achievable in the market. The rental rates then have a very small window of adjustment and need to balance with the financial returns of the project and what the market will allow. One way to create varying levels of affordability within the building is to create variation in unit square footages to allow different price points to residents. As you can see on the floor plan, the central one on the top side is our standard one bedroom, but through various sizes on the south side of the building, we create units that are slightly smaller that'll present different rent levels and allow greater affordability to a greater audience in the community. Next is careful planning of the building amenities. The amount of square footage along with the use of the space will impact costs and energy usage. Both items will influence the overall budget and rental rates on the project. Managing the energy usage of the amenity area is critical in the overall MEP systems and budget for the project. We have found it best to reduce the square footage and make these spaces multi-purpose to keep costs and energy uses down while still providing residents common areas. Another area of impact is the efficiency ratio of typical floor plates, as well as the overall building efficiency ratio. Fine-tuning this to higher percentages will increase the revenue generation for the project, increasing the viability for the project and allowing some extra amenity space or for extra dollars for additional sustainability items for the project. Construction cost is the second biggest factor to achieving affordable units. The project identifies the target market. We have found that there is only a plus or minus 5% window for construction costs to keep the finish and quality level of the project in line with the market and target demographic that they're after. When considering cost savings with PHIUS and Source Zero energy buildings, the simplicity of the structural systems and envelope will go a long way. With the requirements of the exterior envelope, simplicity and form will help contribute to cost savings due to the amount of costs associated with each corner or material transition in the facade. Lastly, we have found fine-tuning the unit square footages to be the best route to create affordable units. There are two strategies here. One is to study the typical units against the market and determine the range of square footages that can still meet the market demand. For example, a typical one bedroom in the market may be 700 square feet, and there can be up to 20% differential in size. If done right, this results in a range of 280 square feet. At $2.25 a square foot for rent, this could mean almost a $300 difference in rent per month for that unit by right-sizing the unit to a smaller size, creating greater affordability for residents in the community. Another strategy is to look at the unit types and create various price points through the unit planning by creating some possibly at 700 square feet and some at the smaller square footages to allow different price points for residents in the area to get into the building. Now, taking the building programming and collaborating with the broader design team is where the real fun begins. We have found that early in the project is good for the entire project team to get an understanding of what the key drivers will be for each discipline in order to achieve Passive House certification as Source Zero energy. Collaboration is the key as the process is very iterative and fluid, with the teams constantly tuning the design throughout the project. Each decision on the project has impact on one another, whether it is insulation thickness that impacts the energy modeling and cooling loads, sun shading devices, window performance, or glazing percentages, and so on. Each time you turn the dial, it impacts the entire team. So now a little bit about the process. Our team started out using contextual cues to inform the massing and proportions of the building elements. Next, we explored the views out from the units and the idea of using balconies to both benefit the units, but also to control solar heat gain. This became a big collaboration item amongst the team to really study the depth and location of the balconies to best benefit both the energy model, but also the units themselves. Views to Columbus Park are an important feature, and we wanted to capture the views through increased glazing in these locations. This meant balancing out the glazing in other areas throughout the building and studying the energy models to make sure that we balance those in the right way. Early on, we explored creating a perforated wrapper around the building to help control daylight and solar heat gain, but through iteration and collaboration, we were able to remove that wrapper and just use the balconies through fine-tuning of the window glazing percentages and also some programming plan changes that happened. Next, bringing up the core elements and creating a rooftop amenity to give all the residents an outdoor space along with views of Columbus Park and the city skyline. The area required for the solar array both exceeded our site area and our roof area, so the team developed a concept that was a folded plane down the south side of the building and up over the roof terrace. This also served to create kind of a exterior room on the roof terrace for residents as they looked over the park. Another aspect of consideration for the solar array was the proximity to other buildings and their potential for redevelopment that could impact energy collection in the future. With the building to the south being protected by a Village of Oak Park historic landmark designation, redevelopment is unlikely, but the next building to the south does not have that same designation. But through a shadow study of potential future development at a similar height to ours, we found it have no impact on our solar array. And this is a view showing the solar array down the south wall and then up over the roof terrace, kind of creating that outdoor room for the roof terrace. Another area of collaboration was the glazing percentages. Our teams, through rigorous study with Tom and Scott, we found the right balance of glazing on this project to get so that we could get key areas like on this southeast corner unit overlooking Columbus Park, and balancing the glazing in other areas so that we could achieve the energy model. Balconies on the project are both an amenity for the units, but also we're using those to control the daylight as well. So here's an example of one of those corners. And here's another view of the solar array that helps create that outdoor room on the rooftop space and amenity areas. Comes up over the top and down the south side. And now I'll pass it over to Scott to talk about technology in HVAC systems and design.
Thanks, Joe. So now that you've all heard a bit about the background of the project, the envelope iterations, and the overall design of the building, I'm going to get into a little bit of the system specifics. So one really interesting aspect of this building is the metering strategy. There will be two main metering groups on the building. One for the house panel, which includes HVAC, common areas, amenity spaces, garage, back of house, etc. And then the second is going to be on the apartment units themselves, all provided by ComEd smart meters, which will include in-unit appliances, lighting, and other plug loads. The PV system is designed to produce enough energy to offset the entire building's energy use. And at this point, it's currently designed to tie back in behind the house meter itself. This is what ComEd is calling an option B community solar program. And that's what we're really going for with the community solar aspect of the building. So the PV system will serve the general service loads first, and then any surplus energy generated will be pushed back to the grid through net metering and later made available for community solar subscribers within the 7 Van Buren building. At that point, if there's even more energy generated and available beyond the use of this building, that amount is then made available to other buildings within the OPRC's portfolio. And this essentially becomes a really interesting and elaborate accounting exercise on ComEd's end. So that being said, let's take a quick look at the HVAC systems approach for the building. Like many other PHIUS multifamily buildings, a variable refrigerant flow or VRF system is being utilized to provide both heating and cooling to all the spaces. Individual high wall terminal units connected to a centralized condensing loop are provided to basically every occupiable space within the building. Because of this, the system provides not only extreme flexibility when it comes to zoning all the individual spaces, but it also enhances both thermal comfort and controllability, which is really important when it comes to keeping your occupants happy, keeping them coming back and renting again over and over. The system results in a heating COP of 4.1 and a cooling COP of 4.2, which is quite good. The heating and cooling is decoupled from the ventilation, which is provided through a centralized dedicated outdoor air system, or DOAS, which has energy recovery built in. And this unit provides a total heat recovery efficiency of approximately 84%, which is also quite high for a centralized unit. A lot of the single family homes in the Passive House programs utilize the fancy Zender units, which do a little bit better than that. But we're finding that this centralized unit is really good when it comes to performance and recovery ratios. So by following the Passive House principles of balanced ventilation, each space is continuously supplying and exhausting fresh air and stale old air, resulting in the most healthy and comfortable indoor living environment. And again, that really goes back to keeping renters happy and providing the best possible situation for everyone involved. Let's move on to realized energy by end use. We found this graph to be incredibly fascinating. It's interesting to see the breakdown of energy use going to the house meter and also the remainder going to the tenant meter. Even with heating, cooling, ventilation, common area, lights, garage, etc., all being on the house meter, it's still maybe only 30% of the total energy use of the building, which is a really incredible thing to see. That being said, looking at the tenant side, so all the individual apartment units, you have 70% plus or minus of the energy use of the building being put on those renters. This is a prime example of what happens when you take envelope performance and system efficiencies to the max. We've really squeezed as much energy efficiency we can get out of the insulation, the HVAC systems, the hot water production. We've minimized those to pretty much as low as they can go. And what happens then at that point is you're left with appliances and plug loads being almost 50% of the total energy use of the building. On a conventional building, you would never see this in an energy breakdown. This is really unique and really finely associated with a high performing building. What makes things interesting there, though, is the largest energy use is something that we as designers have the hardest time controlling. And that really goes into some of the things we're going to talk about next on continuing challenges. So all that being said, we did want to wrap up this presentation with a couple of final thoughts, specifically relating to continuing challenges. The first is on cost. As both David and Tom mentioned, without the ICECF grant program, it's very unlikely that this building gets built this way. We felt that this is a really obvious indication that the market has some catching up to do. And if we as an industry want to make net zero buildings the norm, something needs to happen on that end. And, that could be more strict codes, that could be prices coming down on triple glazed units, you name it. Something really needs to give there. So that's what we need to figure out collectively as an industry. Secondly, we've gone back and forth with occupant behavior and its potential impacts to the overall energy use of the building. Previously, Tom showed you a sensitivity analysis of what happens if there's more energy use at a residential level through TVs, gaming consoles, increased cooking, all of that, you name it. it's a very difficult thing to predict and fine tune. And again, especially given the current state of our nation and many other locations of the world with so many people working from home, that level of energy use at a residential perspective is something that is difficult to quantify right now. And even ComEd doesn't have too much information as to what that increased percentage is. So this becomes a completely different exercise when you're trying to size and design your PV system. Going hand in hand with our energy monitoring at the apartment level, we found that to be an emerging market right now. A lot of the real-time energy monitoring platforms that we've encountered are really meant for a large portfolio of buildings, something like a campus or university where they have 20, 30, 50 buildings they're looking at with 1 meter for the building. That's really where things are right now. So we're chartering new territory, really trying to get the apartment by apartment scale and allowing the individual occupants to understand their individual impacts to the overall building use in a real-time situation. And, you know, that might be something like a phone application where they could see in a smartphone what their individual use is. And then in the lobby or amenities space with the live dashboard for the whole building, they can really see how their individual uses play into the bigger role of the building. And then finally, we want to wrap up with technological capabilities. I hope that everyone who's tuning into this session knows that systems and performance are always evolving. And this makes us question where things might go next. For example, is something like radiant heating and cooling going to become the norm in multifamily? In the multifamily sector, we haven't seen much of this yet. A little bit here and there on single-family homes, mostly radiant heating. But could we get to a point where we start to transition some of the commercial radiant systems into a multifamily platform? And that has different impacts to the life cycle of the building, the carbon emissions, et cetera. So that being said, that takes us to the end of our presentation. Thank you so much for tuning in. We're really excited to start the Q&A portion, and we look forward to answering all of your questions. Thanks. All right. Well, unfortunately, David couldn't stick around, so I'm going to be DJing the Q&A for the panelists, myself included. A little conflict of interest there, but let's see how it goes. I'm going to start the first one off for Tom. It was mentioned by David and you as well that the project is meant to be an example for the Midwest. And it's the first time that ICECF has seriously taken a look at multifamily. Could you elaborate a little bit more on the importance of this?
Well, I think that David came at this very much as a visionary client, which I think a lot of us who are working in this field kind of get to see from time to time, which is great, you know, an inspired owner. He really wants to set an example for Oak Park and for the Midwest and sort of take it as far as he can go. And, you know, while providing great housing. So yeah, that kind of passed quickly in his presentation, but I did just want to underline that he's trying to see this as a bit of a blueprint type building. As you could see from our energy model, we're really at the limit, and we're, you know, kind of concerned that we're going to be able to get all the solar on this building that we need to make it work. But yeah, so I think that the thing that's interesting about this from the grant standpoint is that my experience with them has been park districts and schools. And so I think a lot of developers are not for profits, or they're working in strictly affordable housing. And so they have other means of doing their qualifications and getting funding. So this is a different, it's a bit of a different animal from ICCF. I think we're the only market rate type housing project that they've looked at. So we're definitely having to answer some different questions and get everybody's head together on the project.
Great. Thanks, Tom. Joe, we have a couple questions about some of the balcony and northern glazing strategies, specifically about the properties of the northern glass and how those compare to maybe other aspects of the building. And then in regards to the balconies, what's being done from a detail perspective to really limit and mitigate thermal bridging?
Sure, I'll start out with so the balconies, our approach to that is we have a thermally broken bracket connection along the facade, so that we do have some insulation between the bracket and the envelope on the interior. And we're treating those those brackets are 4 to 5 feet on center, and to space those out so that we're limiting, kind of those thermal break points, and then running framing perpendicular or parallel to the exterior facade walls. So we have a L-shaped metal bracket that kind of hooks down the wall that almost like a knife plate that attaches, that has some thermal insulation behind it actually before it hits the enclosure to kind of help with that thermal bridging. And then on the windows and the north facades, and I would say this was one area where we really worked closely with Tom and his team on the modeling to really dial in what the window performance wanted to be or needed to be to get to glazing percentages that we were looking to achieve. And I think, Tom, I'll let you comment a little bit about what we found in some of the studying with the effect of the balconies. But as far as the windows go, yeah, we're using triple pane, we're using super high performance windows in order to help achieve that, and that helps. But I think, Tom, if you want to comment just on some of the studies and iterations that we did with the modeling.
Sure, yeah. So yeah, they are triple glazed, insulated frames, and argon filled. There's a question specifically, not krypton. And the north, well, what's interesting about working in the energy model, the PHIUS, the WFI passive energy model, is that you're kind of seeing the dashboard and you want all the check marks to be green and not, red X's. And so we go in and change kind of items sort of in large groups, like we'll change the north glazing, alter the solar heat gain coefficient, for instance, or the U value when we get a different window spec, and so we kind of keep working our way around and looking. The trick with this building is very much balancing the heating and the cooling. Since there are a lot of internal gains, it's easier for the cooling load to get too high, or the cooling demand. And yet, in the winter, we want to use the free heat when we need it, so there's like a balance point there, and that really plays out in the glazing. So the glass, I'll say the glass selection is critical everywhere. Typically, we need low solar heat gain coefficient glass at the east and west, because it's very difficult to shade that, and even if you do shade it, you're getting kind of that low angle sun, and that can really peak your loads very quickly. So that's a tough orientation to shade, because if you shade it a lot, so you're not getting your loads, blasted, and your mechanical system all of a sudden has to get really big to deal with it, then you're really not using that glass to seed very effectively. So yeah, low solar heat gain on the east and west for sure, and then, well, and I'll qualify this. In our single family work, we find that we're using very high gain glass, like 0.5 solar heat gain coefficient on the south and on the north in our houses, but that's where we need more help in this climate with our wintertime heat gain. So yeah, so on the north, we're mostly trying to kind of control radiation for the heat gain, and so a certain amount of shading, even the balconies help a little bit. Yeah, I mean, I could definitely continue to get into the weeds here, but that's something that we just kind of keep tweaking in the model until we kind of find that right sweet spot.
Yeah, I'll just add quickly, it is really interesting seeing, the critical shift between smaller single family and multifamily, and really realizing the impact of different things and how it's just so different between the two building types. And it's been both an interesting and a difficult thing to overcome. I'll take a quick question from Nick. He's asking about the metering strategy and if the residents can realize any of the cost savings due to the PV panels. The short answer is we're just not quite sure yet. This is the first time that OPRC is going to have a net zero building. I know that they have some flexibility for the rate, and I think if possible, they are going to be providing discounts to their occupants. And that priority is I don't know if it was mentioned during the talk, but the priority is given to the 20% affordable housing units. Let's see. Yeah,
can I jump? So in talking to David about this, ICECF wanted to be sure that we weren't just letting the monetary benefits flow to the market rate units. They were interested in more of a kind of, I guess I'll call it a public good approach. And so, the reason Scott and his team worked with ComEd to set up the metering strategy that way was so that we had control at the house panel level to determine kind of how the solar credits could work. So basically, we're going to get the solar credits, and they're essentially going into kind of a community solar type arrangement, so OPRC can choose then to use those credits to apply to the affordable housing units, and then other people in the building may subscribe, and that's still being kind of figured out. But otherwise, it goes back to OPRC as a whole to use across their portfolio of buildings. So it's but the grant was specific that they didn't want to just sort of give it all to the units directly.
Yeah, thanks for adding that, Tom. It's good clarification. We do have still a couple more questions here and maybe 5 more minutes. We have a question from Laura asking about research on VRF and refrigerant leaks. I think we're all aware from the carbon drawdown, information that refrigerant is a pretty big impactor to climate change in that, and it is definitely taken into consideration. I think that what we tried to do in the last slide about continuing challenges is hit that on the head and say that systems and performances are always evolving, and we think that we need to always look at all the options and what makes the most sense. And as we move as an industry more towards total carbon footprint and emissions of a building, that's something that's going to kind of be the next thing to fall over for us. I have some questions about project schedule and construction. Joe, do you want to speak to that?
Sure. So let me see where that one is at. So I think construction, we're working through the kind of unique times that we're all in. We're working with the municipality to get in front of them to get our entitlements done and construction started. So as soon as we can figure out that path forward with the AHJ, we'll be working through that and looking to get this started as soon as we can. The team has done a good job getting through kind of design development, so that's kind of where we're at. We're ready to tee up and get construction documents and all the final details of this thing put together. And then as far as construction costs go, can't really share right now what the kind of final numbers are for cost per square foot, but it is running slightly at a premium. But I think with this project, the grant really brings it in line with a normal market rate project. So we're not seeing quite the premium that I think some projects might see, but it's the team's working really hard to simplify the details and the systems to be as efficient as possible and as sustainable as possible. So
do you also want to add in on how the incremental cost works with ICECF and how they kind of figure that stuff out?
Yeah, so for the grant program, we have to look at, and this was a point where, working with ICECF, you really work with them on, what would this project be if it wasn't net zero or source zero? What would this project be? So it's not necessarily code minimum. It's, what would this project be if you were going to bring this to market? And then create a delta from that to, getting it to source zero. So it's a little bit, I think you have to look at, they really want to know what your project goals and drivers are going into it, so that you can kind of define what that base cost is. And Tom, do you want to elaborate any more on that?
Yeah, well, I mean, that is an important thing, I think, for teams to know if they're going to apply for ICCF, is that it's more work. You kind of have to have another kind of base case building virtually designed, or at least with some kind of allowances to know what that other cost is. Yeah, it's not like what would a cheap code building be, and then here's what we want to build. It's really, you need to kind of take your plan with your net zero and say, all right, if we didn't do this, here's what we'd back down to realistically. So, I mean, I know you guys did a lot of work with the builder to figure out those cost comparisons. Essentially what you do in the grant process is give them a spreadsheet that shows two construction cost scenarios. So you can really justify the difference.
Yeah,
they really need to know that.
It really takes a holistic team approach from the design team, the ownership team, and also a general contractor involved, or somebody that can do the pricing estimates from early on, because it's really all those pieces have to kind of work in concert together from the start all the way through the grant process. And then, the real work starts when they start going vertical, and then that first year of service of the building to really make sure that it follows through. So it's really important that the entire team is put together and on the same page, including the contractor, to really see this thing through.
I think we got time for maybe one more. And Tom, I'm going to ask you, one of my questions I've been dying to ask you personally is, this is a big shift from single family home, passive house work. And also, you coming from the design side now being more on the consulting side, do you want to talk a little bit about your thoughts there and how those experiences have been similar, different, better, worse?
Yeah. Well, I'll say that, as having done about a dozen passive house buildings, all of them single family except for the Carroll Center for the Park District, which we just finished. The learning curve getting into this project as an energy code, as a passive house consultant, wasn't huge because we really knew what it took to model. But there are definitely some things to know about using the multifamily worksheet, and there's some specific things when you work with PHIUS on that. But what was great is that Kahler Slater are real experts in this type of work, and they have really great commitment to quality and to design and performance. So so we didn't they didn't look at me and say, what's a thermal bridge? They've been detailing buildings well for a long time. Coming out of Milwaukee, it's a cold climate. So anyway, it's been really a pleasure to have a team like this. It's been a great team. And I see Liz on, so we probably have to wrap up here, but I did see one other question came in. Is Oak Park on board for the bulk and the arcade? And I just wanted to say, as an Oak Parker also, we were all lined up to go in front of the Plan Commission and get that finalized. But David, as a longtime Oak Parker and very politically involved for many years, had many conversations with staff and neighbors. So so it's been discussed. We haven't been through the process yet, and that's coming up. But I think that it's not going to be a surprise to anybody. So the indications are good, but that's where we're at right now, waiting to figure out just exactly how we get through the approval process.
Thanks so much, Tom, Scott, Joe, and David. It's really awesome to hear about all these cool projects that are taking place in Illinois. And we would like to thank you guys for participating in the conference, and also a big thank you again to our sponsors for all of their generous support.